Alright, hi guys, my name is Nick, and I'm going to be presenting on microphones today. So, to start, a microphone basically turns sound waves, mechanical energy from the air pressure, the mechanical energy, into an electrical signal. That is the main job of a microphone. And that electric signal is then sent to like a speaker system or another device that will then reverse that process so you can listen to it. So, a dynamic microphone is the most. Wait, let me get the laser pointer out. Okay, the dynamic microphone is the most basic type of microphone, and how it works is there's a cone structure attached to a coil, and then this structure is then inside of or like around a magnet or surrounded by a magnet, and so the magnet right now is creating a magnetic flux on the coil. However, it's not changing flux until the sound waves hit it, and then it oscillates back and forth. And then since the coil is going in and out, that'll induce a voltage onto it, and then this voltage is in red. But the coil is going in and out, so the magnetic flux will be changing. So there's a changing flux. That's basically how a dynamic microphone works. And so since this relies on the cone to read the sound, it has a lower sensitivity and higher like it won't like distort to very loud noises because of the system. And this is better for recording one voice at a time, just because it can't pick up various like background noises as well due to its low sensitivity. Okay, so then the ribbon mic is very similar to the dynamic microphone in its setup, with the magnets surrounding a thing that will be getting induced voltage. In this case, it's a thin sheet of metal, and what happens is the sound waves hit the thin sheet of metal, and then it'll oscillate back and forth as this arrow shows, and that will induce a changing magnetic flux, which will then cause the induced voltage. And so the ribbon microphone has a lower sensitivity to higher frequencies, and that is probably from just how it's attached to the wires. It's probably a little bit more constrained than the cone, and it is also fragile just physically because of this that it relies on this thin metal sheet, and then this thin metal sheet is also a conductor. Okay, the condenser microphone uses a capacitor, and so how this works is that there's a capacitor in a circuit, and the sound waves will hit this capacitor, and then that'll draw the two plates closer together and then farther as they oscillate, and then that will cause a change in this D value in this capacitance equation. So since the capacitance is changing, that is changing the current and the voltage, or just the current, and so that will be read through the electrical signal, and then this resistor is here to complete the circuit. And this is just a simple diagram of how it works, but this is the more like industry standard, and it's a little bit more greasy because it has like a backplate and a diaphragm and then these spacers. And so what happens is that the diaphragm will be vibrated from the sound waves, and then it'll draw closer to this backplate, and both of these are conductors. So these two pieces are acting as the plates, and then it's getting its charge from a phantom power. It's just called that because the phantom power is an outside external source, just as this purple voltage source is in this example. And so the phantom power has no effect on the electrical signal given by the capacitor. So yeah, thank you. Oh wait, and so disadvantage of a condenser microphone is it needs its own voltage, but is also much more sensitive. So it allows to give like the overall, it can capture the overall timbre of like a orchestra or like an instrument. It's much more fine. However, in the smaller condenser microphones, this circuit does create a small noise which can influence a recording. So that is another disadvantage. Thank you for watching a Jonah's Lemonade production.
Illumination! Illumination! Illumination!